Hello there, Nareg is here. Today I'm gonna solve the second exercise from the first session of 2019 chemistry. It's already related to electrochemistry, so let's start. Electrochemical cells. An electrochemical cell converts chemical energy into electric energy. Several metals can be used to construct cells. Metals differ in their tendencies to lose electrons. For example, copper, Cu, has more tendency to lose electrons than silver, Ag, and it has less tendency to lose electrons than magnesium, Mg. The greater the difference between the tendencies of metals to lose the electrons, the higher the voltage of the cell. An electrochemical cell G1 is constructed in document 1. Document 1 shows the schema of the functioning cell G1. So we have the functioning cell G1. Identify the metal 1. The metal 1 should be copper. So the metal 1 should be copper. Since I have to place the metal copper in a solution containing ions of the same type as the metal. So the metal should be copper, since I'm placing it in a solution containing the same type of ion, in this case Cu2+. The overall equation of the cell reaction G1 is given below. 2Ag plus Cu gives 2Ag plus Cu2+. So this is the overall equation. Show using oxidation numbers that the above equation corresponds to an oxidation reduction reaction. Very simple. So in order to do that, you have to say 1.1 to 2.1. So we have 2Ag plus Cu. It will give you Cu2+ plus Ag. Now, by using the oxidation numbers, for Ag plus it's +1, since its charge it's 1 plus. Cu is 0, it's a simple element. Cu2 plus it's +2, again the charge is +2, and for Ag is 0 since it's a simple atom. So for Ag, the number of oxidation is decreasing from +1 to 0. The number of oxidation is decreasing, so we have, in this case, a reduction. As for the second case, for copper, the number of oxidation was 0 and it's increasing towards +2. So the number of oxidation is increasing, so I have an oxidation. Since I have reduction and oxidation, so this reaction is oxidation reduction reaction. So it's oxidation reduction reaction. All right, now what about write the half reactions that take place at the anode and the cathode of the cell G1. Of course, it's simple to identify which is the cathode, which is the anode. You have to say Cu is the anode. Cu is the anode. The half equation of oxidation will be Cu is being transformed to Cu2+ by losing 2 electrons. Ag is the cathode. The half equation of reduction in this case will be Ag plus 1 electron, it gives you Ag. All right, so this is the reaction that you have, the half reactions that you have for copper and Ag. Now, justify the following statements. The mass of copper strip decreases after a certain time of the functioning of cell G1. Of course it will decrease, since the reaction that we have in this case, we have Cu being transformed to Cu2 plus by losing 2 electrons. So Cu is going through an oxidation. By oxidation, we mean that Cu solid is being transformed to Cu2 plus ion. That's why the mass will decrease. Now, when the salt bridge is removed, the lamp of the cell G1 doesn't glow. So it's very simple. The salt bridge, actually, it will help to have a closed circuit in this cell G1. So whenever the salt bridge is removed, the circuit will be open, so the lamp, or yes, the lamp of the cell G1 won't glow. So this is for this part. Referring to the text, answer the following question. Arrange the metals copper, Ag, magnesium on the axis according to their increasing tendencies to lose electrons. We already talked about that Mg is losing electrons more easily than copper, and copper more easily than Ag. So you have to simply do an axis where you have the tendency to lose electrons. The metal which has the highest tendency is Mg, and then you have the copper, which is less than Mg, and finally you have Ag, which is, of course, in this case, silver. Okay. A cell G2 is constructed by connecting the two half cells. A magnesium strip Mg dipped in a solution containing magnesium ions Mg2 plus, a silver strip Ag dipped in a solution containing silver ions Ag plus. Give the symbolic representation of the gels of the cell G2. So this is 2.2. So in this case, I'm constructing a cell formed by Mg and Ag. Since Mg has a higher tendency to lose electrons than Ag, so Mg will be the anode. As for Ag, it will be the cathode. All right. So how do I represent this? Represent this cell? Very simple. You simply have to say that it's Mg, Mg2 plus, salt bridge, and then Ag plus Ag. This is how you construct your cell formed by Mg and Ag. Conventionally, Mg is on the left side since it's the anode. All right. So this was the anode and cathode. All right. Under standard conditions, the voltage of the cell G1 is U1 0.46. 0.46, yes. So this is the cell G1 that we have. It's between copper and silver. It has a voltage of 0.46. Now choose the following values. From the following values, the one that corresponds to the voltage U2 of the cell G2. G2 is between Mg and Ag. As you can see on the axis, Mg and Ag are separated, are distant. Mg and Ag are quite distant regarding Cu and Ag. So the voltage will be higher. Why? They already mentioned in the text, the greater the difference between the tendencies of metal to lose electrons, the higher the voltage of the cell. So we have Mg and Ag. They are quite distant, so the voltage will be greater. Of course, if the voltage of the cell G1 is 0.46, it will be greater than 0.46, and you will have to choose 3.0 0.17. 0.16 is less and 0.46 is for G1. All right, that's all for this exercise. This was the second exercise of first session 2019. Why don't you subscribe to my channel, because I will upload new material. I will solve other sessions, other exercises, of course, related to chemistry. I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time, and see you later.